Hi everyone. So first I would like to introduce myself as my name is Dr. Vijay Bhaskar Reddy, Associate Professor at Department of STS in the Chemistry Department. I'm handling environmental science subject. So today we are going to discuss about the noise pollution. So the overview of the noise pollution mainly discussed the key points or key parameters in this today lecture is what is the noise pollution, what are the sources of noise pollution, what is the sound frequency, and the central pollution control board, what are the actions will be takes place, and effects of whatever the disadvantages of the noise pollution, how to control the noise pollution, along with some of the sub criteria is the noise and the sound and their characteristics and their units, how to express the sound or noise, which units are using, range of hearing for the human beings, if over the noise sound, what happen, and the sound pressure, decibel scale, the sound levels. These are all the points discussed in the today lecture. Now we are going to discuss about what is the definition of noise pollution. So noise pollution means unwanted noise dumped into the atmosphere. So whatever that will be dumped into the atmosphere, noise will be dumped into the atmosphere. So that will be leads to discomfort and health hazards is known as the noise pollution. So generally 90 decibels is the sound levels are permissible for 8 hours per day. So means 90 decibels of the sound is permissible for 8 hours a day. If beyond that, a lot of problems are coming. So different decibels, how to scale converted, that also discuss that one. So what are the sources, main sources of the noise will be polluted, where this noise is coming into the environment or atmosphere. So first, from the natural source, natural phenomena is a violent volcanic eruptions. When the volcanoes erupted, thunders, fierce storms, these also create a lot of noise that will be entering into the atmosphere. Is the some domestic and artificial, like that one, domestic appliances used for our daily purposes, like mixers, grinders, washing machines, telephones, and some of the industries are working as a mills, factories. These are all will be created the some of the sound or noise, and that noise will be entering to the atmosphere. So like some of the trains also, ships and aircrafts, and bursting of crackers. Every day we are every year we are celebrating our festival Diwali. On that day we are fire the crackers. That also lot of noise producing into the or enter into the atmosphere, and playing loud music during the social gathering and festivals. That also sound will be creating how much sound pressure is coming, how that converted into the decibels. We check in the next slides. So entertainment devices such as radios, television also created some more sound is coming enter into the atmosphere or environment. These are the major sources of the noise pollution. Now coming to the sound is a form of energy. So not a simple one, that also one form of energy that will be propagating or vibrating from one place to other place. So means is a sound is a energy. So unlike a mass based pollutants. So noise sufficient intensity or duration can result a permanent or temporary deafness is coming. For example, a noise is a sufficient intensity, a duration can be leads or result in a permanent or temporary deafness or hearing loss is coming. So noise is a major occupational hazard for industrial workers. So who are working long time in the industries, when the more noise is produced, that industry also is major occupational hazard for industrial workers. Now coming to before going to some of the discussions, how the sound, noise, what are the units, how that will be propagating, some of the basic things we learned in this slide. So here is the sound wave need a medium. So means sound will be propagating from one place to other place. Is the must required a medium. So like now pass through the, unlike a light. Light no need to that any pass that one. But this will be must a medium is required. The sound waves vibrations pass through the fluids. Fluids means either gases or liquids or solids also. So means that also that vibrations, whatever sound vibrating from one place to other place, either pass through the gases or liquids or solids. So here the sound waves alternating wave compression or refraction. So means when the wave will be propagating, is both reactions is either compressing or rarefaction, which results in a local changes in the air density. So means when the wave will be propagating, so that wave propagating, some of the compression and rarefaction will be takes place. During these two happens, so immediately that will be leads or result in the local changes in the air density. So whatever these two parameters will be influencing on the air density, so immediately a pressure will be created. So these pressure changes detected by the human ear. So that generally already in the basics of the C considered as a speed of sound, that will be meter per second. And frequency, what is the frequency means the number of times of peak or trough arrives within 1 second of the oscillations. So that will be expressed in the hertz or hertz seconds inverse. Period is a time between the two successive troughs or peaks. So means this is the one trough and the successive, what is the how much time is there, that is the period. Amplitude means height, how much height that wave will be propagating. So means height of the peak or depth of the trough with respect to zero pressure level. So means this is the zero pressure level. From this considered a base point, how much height will be either trough or depth, that is called the amplitude of that wave. Now wavelength is the distance between the two peaks or two troughs in a sinusoidal sound wave is called the wavelength. These are the some of the basics. So simply say a sound is the one type of energy that will be propagating or vibrating in the waves. So from one place to other place. For that is a medium is required. That medium is either solid or liquid or gases, whatever that is the propagating. These are the some basic points for related to the sound. Now this is the consider as a whatever this one is whatever is the sound energy. Here is the below 20 Hz, that will be considered as a infrasound energy. So that energy will be considered as a infrasound energy. And between the 20 Hz and 20 kilohertz is between the whatever the blue line will be indicating, that is the human range of hearing sound. So 20 Hz to 20 kilohertz. Above 20 kilohertz, that will be considered as a whatever that one is a 200 megahertz. Up to this one, a green color indicating that one is a ultrasound energy, that one. So here is the only this blue line region, only 20 Hz to 20 kilohertz, that sound will be human will be range and hearing that one. That is the scale, the nature of the sound. So here is the some more basics. So the human range hearing is the 2 into 10 to the power of minus 5 Pascal or 200 Pascal pressure. That whatever is the sound level pressure will be hearing human range. Human hearing the 7 to 8 orders of the magnitude of the sound levels. So that is the considered as a magnitude of the sound vibrations of that one. So here is the whatever these two scales, log scales for the measuring these two variations. So units for the sound level is the considered as a first initially is the bell. So this is coming to the after Alexander Graham Bell. The first measure the units for the noise or sound is the bell. So that will be bell is one of the mathematical expression. L is equal to or L prime is equal to log Q by Q naught. Q by Q naught. Here the expression, that is the bell L is equal to, here is the L means sound level or bells. The sound level will be measured in the units is the bells. That bells is the, whatever is the sound levels will be mathematically expressed. Equation is the log Q by Q naught. Here is the Q, what is the happen is the Q is the measured quantity. We are measured quantity. And Q naught is the reference quantity. You take the reference quantity. Already known reference quantity, you take it. Then the measured quantity Q. So that is the logarithm of. So here is the bell is when divided by 10, you give the decibels. When the bell is coming, that one, so that will be divided by 10 to converted or give the value is called the decibels. So several methods for the measuring of the sound. How that sound will be measured, what are the parameters considered for the measuring of the sound. There are different methods, parameters considered for the measuring the sound. First one is the sound power level. Sound power level. So based on the sound power level, that will be considered as a LW. LW equal to the 10 log W by 10 to the power of minus 12 with reference to the power level. Is a whatever the sound power or sound energy is the rate at which work is done in watts. So means this will be expressed in the sound measuring in terms of with respect sound power level. For example, if the sound intensity level, how sound will be measured. So that formula is equal to LII means intensity level 10 log I by 10 to the power of minus 12 with reference to intensity level. Here is the whatever sound intensity is equal to is the whatever work energy or work done by area. So that will be units are coming to the, so this one is the watts per meter square. So now coming to the sound pressure level, also we can measure the sound that one. So here is the sound pressure level. So means here the LP means sound pressure level 10 log P square root mean square divided by P square root mean square at the reference. 0 means reference. So this will be converted or calculated in the simple way. So whatever square will be converted to the 20 log P RMS divided by P RMS reference. So that will be considered as a 20 log P RMS by P RMS 0. So here is the reference level. We are taking the reference level is a 20 micropascal. 20 micropascal, that will be equal to the 0 decibels. So we are taking the reference level 20 micropascals. So that equal to the 0 decibels. That is the threshold of human hearing. So that is the whatever considered as a reference level. These are the some of the basics for the how sound will be measured in the different methods. Either the power level will be considered, either intensity level will be considered, or the pressure level will be considered. So these are all will be considered to measure the sound. Different mathematical equations. Now we go the what is the scale of the decibel scale. The decibel scale. So decibel scale is a logarithmic scale. Already in the previous slide we discussed about the bell is 10 divided by scale. So here is the which means change from, for example, 10 decibel to 20 or 30 or 50 decibels equal to change by 10 times or 100 times or 10,000 times. So what is the meaning of this one? For example, the simple way expressed or explain that one. A. So 10 decibels means 10 log 10 into 1. So that will be considered as a 1 into 10 log 10. So that is the a simple first 10 decibels we consider that one. For example, a B, a 20 decibels. 20 decibels means 10 log 10 into 2 or equal to 2 into 10 log 10. So means B is 10 times sound louder than. So means here the sound pressure will be considered or sound intensity will be considered. So means is a 10 times sound louder, sound intensity louder than A. Okay, not the whatever is the double that one. So here the consider as a subsequently 30, 50 also like a 10,000 times sound intensity or sound pressure louder than A. So louder than means here the either sound pressure or sound intensity. Now coming to the here the how sound pressure level SPL, sound pressure level micropascal, that will be converted to the decibels. So what are the perceptions will be a different conditions takes place. Here is the first we consider as a 20 sound pressure levels micropascals, that will be already reference level equal to the 0 decibels, that is the threshold hearing. Now convert to the here is the how to convert, what is the mathematical equation is there, sound pressure levels to decibels, sound pressure levels to decibels. Here is the LP decibels, 20 log SPL. SPL means sound pressure level, root means square, divided by sound pressure level, root means square, reference. Where is this terminology will be equal to that one. Here is the reference, we are taking the 20 micropascal. Reference we are already taking the initially 20 micropascals. So this value is the 20 micropascals. So based on this equation, we calculate the, we converted the sound pressure level into the decibels. Now here is the taken the 20 reference, that will be equal to the 0 decibels. So that is the threshold limit value. For example, if the 100 micropascals of sound pressure level is there, that will be converted into the decibel scale is coming to the nearly 14. So that will be perception means in the study room. Study room means is a very low noise, no sound will be produced. If go whatever sound pressure levels is, so whatever the decibels also slowly increasing. For example, we take the one of the whatever room with air conditioner, so that sound will be producing near the sound pressure level is the 20,000 micropascal, that will be converted into the 60 decibels. Like a heavy truck 90 decibels are producing, nearly sound pressure level micropascal 6,33,000, that will be converted into the decibels, is nearly 90 decibels are coming. Power lawn mower, rock concrete, jet taking off at 100-meter distance. So this will be this much of the 125 decibels of the sound level will be producing. For example, threshold of pain is this one is the 130, is a jet engine at a 25-meter distance, 140 is the decibels are producing. So means when the jet engine coming to the 25-meter distance, so means very close to the jet engine, so that time that jet engine will be producing nearly 140 decibels. So that will be equal to the this much of the sound pressure levels is converted to the decibels. These are the sound pressure levels converted to the decibels in the sound levels, and what are the perceptions related to different parameters. So this is the mathematical equation for the sound pressure level conversion to decibels. Now coming to the some of this one, no, which noise can cause damage? So which decibel sound levels will be cause damage? Which one will be a threshold limit value? So based on this information, we know that one. So which noise can cause for damage? So where hearing protection, when you are involved in a loud activity, so that will be nearly 85 decibels. So regular or prolonged exposure to noise are above 85 decibels, average and 8 hours per day are considered to be hazardous. So means what is this one? So continuously 8 hours per day you are whatever that much of the 85 decibels are hearing through the your ear, so that will be coming to the consider will be hazardous. For example, if the 100 decibels regular and prolonged unprotected exposure of, for example, you did not protect your ears, either cotton or earbuds, nothing, you are regular or prolonged and exposure to the more than 15 minutes, so means more than 15 minutes, so above or equal to the 100 decibels of the whatever noise or sound will be taking your ear. So days 15 minutes per day, risk permanently hearing loss will be happen. So for example, if more 110 decibels regular or prolonged unprotected exposure more than 1.5 minutes per day risk permanent hearing loss. So means if more noise or more sound will be hearing either 1.5 minutes or 15 minutes or 8 hours per day, so slowly that will be hazardous and permanent loss, hearing loss will be happen. So here is the examples of the noise levels. Here the different noise levels are example given. 194 decibels will be loudest possible tone. This is the maximum 194 decibels. So that will be converted to the pressure level also. So a lot of pressure is coming, sound pressure. So our rocket launching, when the rocket will be launching in the space organizations, different space organizations in the world, during that time, how much is sound or noise is producing nearly 180 decibels. You take the jet engine at a takeoff time. When the jet engine will be take off, also 140 decibels are coming. So our ambulance, daily our ambulance for taking of the patients from one place to other place, that ambulance siren also giving nearly 120 decibels of the noise is producing. If you take the hammer drill, when you are drilling your wall with the hammer, that also giving 114 decibels, and chainsaw 108, and bulldozer spray. These are the different whatever is giving to the different decibels. Even our tractor, when you are tractor continually doing for the agriculture purpose, so that also producing 96 decibels of the sound noise is producing. Is the hair dryer ringing of the telephone 80 decibels, and the normal conservation, whatever we are talking to normal conservation, that time also sound will be nearly 60 decibels are there, normal conservation conversation time. So nearly 60 decibels of the sound noises are producing. These are the different types examples of the noise levels at different machineries, different jet engines, or when during the takeoff time producing the noise in decibels. Now coming to the standards, these whatever noise is producing, some of the control boards required. For that purpose, Central Pollution Control Board is a committee has recommended and permissible noise levels for different locations. For example, here there are 4 categories are taken: area of coach, and a category of area or zone, and daytime how much is a limit in decibels, and nighttime how much is a limit and permissible. For example, category code A, industrial area. Industrial area means a lot of industries are working in the daytime, mostly daytime, and some industries are working in the night time also. In that area, as for the Central Pollution Control Board, that will be daytime is 70 decibels and the night time 70 decibels. This is the 75 daytime and the night time is the 70 decibels. And the commercial area is the daytime is the 65 and the night time will be a 55. And residential area, who are living the different flats, apartments, villas, residential areas, that time daytime will be 55 and the night time will be 45. And the silence zone, like libraries, reading zone, that place daytime will be 50 and the night time will be 40. These are the different limits in the daytime and night time as per the categorized by the Central Pollution Control Board in the 4 categories. So what are the effects will be takes place when the noise pollution happen? So these are the ear structure, but I'm not going to that much of the depth of that one. So here is the major psychological disorders like anxiety, insomnia, high blood pressure, fatigue. These are all the health related disorders are coming when the more noise will be hearing through the ear. So loss of working efficiency also. For example, if you continue, the more noise is created, efficiency of the working also loss. So not concentrated on that particular concept, particular work, not efficiency, not completed that work because this noise will be disturbed. Annoyance means a lot of irritation is creating. A lot of irritation is creating during the work, during that time. So decline the number of migratory birds at noise places. So when the more noise is producing in the atmosphere, some of the migratory birds that will be reduced or decreased or declined. So because is the more noise is there, for that noise also that birds not able to migrate from one place to other place, that also decreased or from noise levels. Now coming to the what are the how control the noise pollution, what are the measures control the noise pollution. So generally workers in factories should be provided with earplugs and earmuffs when who are working in the industries. So that must be provided to the earplugs and earmuffs. So vehicular noise can be reduced by keeping the engine clean, because when the engine not clean is the some during the time a lot of noise is created. So means vehicular whatever automobiles is frequently that engines will be cleaned, automatically reduce the noise levels. Industrial noise can be reduced by keeping the machines well serviced. So when the frequently machines will be serviced in the industries, always noise will be reduced and friction will be reduced. So noise machines should be placed in special glass or wooden cabins. So when the industries are working the most noise machineries, in that place either will be closed with the either wooden or glass, because these are will be not some of the reduction of the noise levels to the outside. Special silencing devices should be designed for aircraft engines. Some silencing devices and reducing the conversion of the sound levels, noise levels conversion. So using for the aircrafts. More number of trees should be planted since they are effective sound absorbers, because the sound is nothing but energy. So some of the whatever number of trees should be planted since they are effective sound absorbers. If the more plants will be there in that place, whatever sound will be maximum absorbed by the trees, because the energy used. Public awareness should be created, because this is a very important point. Who are celebrating is the festivals and functions, a lot of noise will be creating that, so everybody will be aware that one reduce the noise pollution. So in this presentation we discussed about the noise pollution, different what are the units, how to conversion of the sound pressure levels to decibels. So which one is the threshold limit value, what is the reference value, these are all the key points are discussed in the noise pollution. So in the next lecture we discussed about the solar energy. Thanking you.